And good morning again. Happy Wednesday. And again, we know you can't be completely happy on Wednesday because you miss your teachers. All right, we miss you too. But we always look for the silver lining of the cloud, right? We make lemonade when we get lemons, and we make the best of what we can. So we're going to make the best of what we can this Wednesday, get a lot done, and get those grades up, right? So you know the drill. Copy all this down, go try it, and then come back and see how you did or get help, right? Okay, we'll see you soon. Back again. Looks like we put the blue pen aside, grab the red pen now. And what two numbers have a product of 100 and a sum of 29? Right? Remember, the answer to the multiplication problem is a product. The answer to an addition problem is a sum. Two numbers multiplied together equal 100 and added together equal 29. That is going to be the 25 and the 4, right? 60 and 19. How about that one? This one I was thinking money. Give you a hint. This one I'm thinking the clock. Clock. Yes. How many minutes in an hour? 60. And a quarter hour is 15. So 4 times 15 is 60. 4 plus 15 is 19. All right. Tough one here. 28 10,000ths and 11 hundredths. I know 7 times 4 is 28. 7 plus 4 is 11. I wonder if this would work. 7 hundredths and 4 hundredths, right? 4 times 7 is 28, but I had to move the decimal over 2 spots here to make that a 7, 2 spots there to make that a 4. So I have to go back 4 spots. 3, 4, and if you've been watching, you know that I say to put those zeros in, I say fill in the egg carton because it kind of looks like an egg carton. Hey, Easter's coming up soon, right? All right, and when I add decimals, I have to make sure that I stack them and line up the decimals. And when you stack 4 hundredths and 4 hundredths and go to add that, you end up with 11 hundredths, 4 hundredths and 7 hundredths. I misspoke, huh? Yeah. Not the first mistake I've made today. It's just the first one you caught. All right, 15 and 10 and 2/3. That is just a wacky one, right? What is going to work there? How about this? 1 and 2/3 plus 9 is 10 and 2/3, and 1 and 2/3 times 9, I have 1 9 and 2/3 of a 9. 2/3 of a 9 is 6, and 9 and 6 makes, so that's going to work there. All right. Adding and subtracting integers. The key here is subtracting one number is like adding its opposite, right? Subtracting 3 is like adding -3. Subtracting 3 is like adding -3. That is a key when you subtract. Okay. Now I realize you've been doing 8 minus 3 since you were 6 years old, and you know that's 5. Then I tell you to, instead of subtracting 3, add -3, and now you have to think to yourself, I have $8 plus I owe 3. When I go pay that 3, I'm still going to have 5. And you think, why would I make that problem harder? Well, when you're dealing with a bunch of integers, if you get in that habit of, instead of subtracting a number, adding the opposite, when you get to problems like this, you're less likely to make a mistake, because so many kids here think this is going to be -5. But think about it. If you are on the number line and you're at -8 here and 0's over here, right? If I subtract, I'm supposed to go that way on the number line, right? And it's easy to see on the number line. I'm going to subtract 3. I'm going to go -9, -10, -11, right? But without the number line, just seeing the problem, it's so easy to make a mistake. But when you think money and you see this problem, you think I owe 8 plus I owe 3, you realize you owe 11. So this becomes an easier problem than that, I think. And a lot of students have told me, Mr. Daniel, when I do those integer problems, I just, instead of subtracting, I always just add the opposite, right? And it is a little bit more work, but I think it's a good way to make sure you get it right, okay? This is -11. Okay, because subtracting 3 is like adding negative 3. Subtracting 3 is like adding negative 3. That's why these answers are the same, these answers. All right, 12 minus 5 is 7. I have 12 plus I owe 5. I have 7. Negative 12 minus 5. If I'm not looking at a number line, I'm likely to get that wrong. But negative 12 plus negative 5, I owe 12 plus I owe 5. I almost always get that one right. All right, so negative 12, I'm at negative 12. I'm going to go 5 more spots to the left. Negative 13, negative 14, negative 15, negative 16, negative 17, right? Okay, 6 minus 2 is 4. I have 6 plus I owe 2. I'm going to pay the 2 I owe. I'm still going to have 4. I owe 6 plus I owe 2. I owe 8. And if I owe 6 and then I spend 2 more, go to the left 2 more, negative 8. Subtracting a negative is like adding a positive, right? Subtracting a positive is like adding a negative, okay? Subtracting, okay, we don't have any subtracting negatives here. We'll do some of those tomorrow. 10 minus 4 is 6. 10, I have 10 plus I owe 4. I'm going to pay the 4. I'm still going to have 6. I owe 10 plus I owe 4. I owe 14. I owe 10 and I spend 4 more. I'm going to owe 14. Okay. All right. Generic rectangles, when you're multiplying, we usually use it with big numbers, but you can use it with mixed numbers too. I think it becomes easy. So I have this 2 here, and I'm going to have that 3 and then 1.5. 3 times 2 is 6, and 1/2 times 2 is the same as 1/2 of 2, right? Which is 1. Or you can think of it as 2 times 1/2. Multiplying fractions is what? Hopefully you screamed, easy, and woke everybody up who wasn't already awake. And how do I make this a fraction? Watch this. All these steps to make a whole number a fraction. Boom, boom. Just put a 1 under it. 2 times 1 on top, 2 times, or 1 times 2 on the bottom. 2 over 2 is 1. So that's 1 whole. So 3.5 times 2 ends up being 6 plus 1, 7. Okay? The other way of doing that is using the C method on the mixed number. 2 times 3 is 6 plus 1 is 7. You end up with 7 over 2 times 2, but you make it a fraction, and you end up with 14 on top, 2 on the bottom, and simplify. 2 goes into 2 once. It goes into 14 7 times. 7 over 1 is 7. All right, same idea here. We're going to have an 8, and then we're going to have a 4 and 2 sevenths. 8 times 4 is easy. 8 times 2 sevenths is 8 over 1 times 2 over 7, 16 sevenths. Now, that's improper. I'm going to divide the bottom into the top. 7 into 16 goes twice. And then my remainder, that 2 is going to go on top, and the 7 goes on the bottom. So 2 and 2 sevenths and 32 is 34 and 2 sevenths. Okay? All right. A little trickier because this is a true generic rectangle when I have 2 and 1/4, 2 and 1/2. 2 times 2 is 4. 2 halves is 1 whole. 2/4 is 1/2. And 1/4 times 1/2 is 1/8. So 4 and 1 is 5 plus a half plus an eighth. Okay, so I'm going to change that halves to 4/8. 4/8 and 1/8 is 5/8. So 5 and 5/8 is your answer there. Hopefully you got that right. Area. If you can think of it as a rectangle, you know how to get the area of a rectangle, right? This is 6 rows of 10 columns, right? How many little squares? 6 times 10, 60 square inches. For a parallelogram, can I make it a rectangle? Yes, this line is parallel to that line. That means they go at the same exact angle. So if I chop off this rectangle over here and slide it over here, it'll fit perfectly right there because it's the same angle. But now that's gone because it's over here. I've made a rectangle. Now, how long is it? You say, well, it was 10, but you chopped that off. But wait, I glued it right back on. So it's still 10. How tall is it? This side is going to be the same as the height. So that is also going to be 60 square inches. The area of a parallelogram is how wide is it times how tall is it. The numbers you need are the ones that make the right angle, the perpendicular lines. Remember, perpendicular lines are the opposite of parallel. They're the ones that meet as fast as they can. Parallel lines never meet. All right. All right. So parallelogram, this is a special parallelogram. You can see all four sides are the same, kind of like a square, but it's not a square, right? What's that called? A parallelogram, a quadrilateral, right? 4 lines, a polygon, many angles, right? But the most specific name, specific means it tells you the most about it. 4 equal lines, it's a rhombus. You can't have a rhombus. It's not also a parallelogram. That's not also a quadrilateral, and all quadrilaterals are polygons, right? So the rhombus tells you the most. It tells you all 4 sides are the same. Okay. So a parallelogram, though, to get the area, I need how wide it is times how tall is it. Okay. Now this, they tried to fool you. It's just a parallelogram sort of turned sideways, right? So you're going to do 9. Again, the lines that make the right angle times 7. 63 square meters. That's a shortcut for saying square, right? Because something to the second power is squared. So inches to the second power is square inches. Okay. Meters to the second power is square meters. Okay. Hopefully that makes sense. All right. Last few. You are dividing with decimals, but you're dividing a decimal by a whole number. Remember, the first number goes inside the box. Okay, now get ready to write yourself some notes here so you can write yourself a note. What do I do if there's a decimal inside the box? Well, you have to learn all those steps. Okay, I'm kind of joking with you, huh? It's kind of like all those steps to make 2 a whole number. Boom, boom. There's only one boom on this one. All you have to do if there's a decimal inside the box and a whole number outside is bring the decimal up. All you have to do if there's a decimal outside the box or inside the box and a whole number outside is bring the decimal up, and then you start dividing, right? So 5.76, 18, the decimal comes straight up. Then you start dividing, right? So 6 goes into 25 4 times because 4 times 6 is 24. Bring down the next number. 6 goes into 15 twice. 2 times 6 is 12. Bring down the next number, and 6 fits into 36 perfectly 6 times, right? 5 goes into 23 4 times because 4 times 5 is 20. Bring down the next number. 5 goes into 34 6 times because 6 times 5 is 30. Bring down the next number. 5 goes into 47 9 times because 9 times 5 is 45. Bring down the next number, and 5 fits into 25 perfectly. Okay. 18 goes into 57 3 times, because 3 times 18 is 54, right? 3 times 18 is the same as 3 doubled, and half of 18, 6 times 9, same answer, right? Okay, and I bring down the next number, and 18 doubled, or times 2, is 36. Now, real quick, if you're still paying attention, you have integrity, you also have 3 of the problems on today's homework done, right? You might see that 25.56 divided by 6 is right there. And this word problem is 234.75 divided by 5. And this word problem, you don't care about that 3, it's trying to confuse you, is 576 divided by 18, and you did that one, all right? So I did hopefully the 3 hardest ones for you, or you did those with me, and now you have an advantage over the kids who didn't watch the warm-up, okay? All right, have a great Wednesday, everybody.